Thank you very much for the presentation. So my name is Duy-Hieu Bui. I come from SISLAB from Vietnam National University, and it's our honor today to present our work on research and development activities on RISC-V and its application for IoT. So my presentation will contain 5 parts. First, I would like to introduce a little bit about SISLAB, and after that, I will talk about the RISC-V ecosystem for IoT application. Then we will present some part of our work and demonstration using RISC-V open source ecosystem. And after that, we will present our research direction and training. And finally, there are some conclusion. So let's go to the uh, introduction to our lab. So our lab is VNU, Vietnam National University Key Laboratory, focusing on system on chip and network on chip design, low power technique, IoT and AI accelerator. We also focus on fault tolerant and design for tests, and in general, it's very system integration design. So our lab was established in 2016 by the president of VNU, and along with that, we have funding for software tool and hardware tool for prototyping. Currently, our lab has about 23 members, mostly PhD student and undergraduate student. There is only one master student, and we also have quite a lot of collaborator and visitor during this time. We are one of we are one among some VNU-key Laboratory. So we receive funding from VNU for the hardware design tool. For example, we have a license for Synopsys EDA tool until 2020, and also some hardware for prototyping, for example, the hub system, and a lot of Xilinx FPGA, Vertex 7, Actis 7, and Ultrasoft. And for Vietnamese people, so to have this tool and hardware is quite hard. So actually, right now we are open this tool and hardware for our company, startup in Vietnam, and also for foreigner collaborator through collaboration. We also have strong collaboration with many university in Japan, for example, the UEC and the University of Aizu. And we also have collaboration with some um, industrial partner, for example, Toshiba. And we also have strong connection with university and research institute in France, where I and my professor has been graduated from. And next, I would like to introduce about the RISC-V ecosystem for IoT application. Firstly, let's look at how the IoT is organized. So the IoT contain many sensor nodes which have a wireless communication, and it can receive, it can collect data and send to the cloud through the internet, or it can receive command from the internet to um, to react to the trend of the environment. In our work, we focus on the IoT sensor node. We need the ultra low power, ultra low energy consumption for app device. And this is some of the key issue in related to the IoT ecosystem. So the first issue is about the different IoT workloads. For example, the sensor node and the app or gateway device need different computation workload. Even for the cloud computing, they also need different workload. And sometimes we need on-demand and configurability capability for the processing. Another issue is the security and privacy. Sensitive data collected by the sensor node might be stored or transmitted through unsecured network, um, and also the application separation. Uh, and one of the key challenge for the IoT sensor node is the low power and low energy, because if we can go to low power, we can um, um, our device can work longer with the same battery. And it's always a big challenge for low power in the LSI design. And the IoT sensor node might also need the intelligent capability, which we need to cooperate AI to the sensor node to make it smarter. And let's look at the RISC-V and open source ecosystem for IoT. So there are already some system on chip platform with which is ready to use. For example, the C5 or the chipyard, and especially the platform from POOP, which have the target for ultra low power. So we can use processor, for example, rocket chip or Ariane um, or RISC-C processor. We can have different simulator, for example, open source simulator validator, FireSim, which can simulate on FPGA. There's also some configurable IP, for example, the SHA3 or test chip IP from Chip Alliance. There's also different interconnect technology, for example, AI4 tiling and even network on chip. For library, we also see that there's some very interesting library, for example, the BSG BASAM standard template library, which contain many IP, for example, a clock generator, open source clock generator, asynchronous FIFO synchronizer, some IP for communication on chip network, and they also provide some file which related to the technology, with for specific technology. And for security, there's already some framework, for example, the Keystone or the HackFi security. Keystone is more focused on the security at the OS level. HackFi is for ultralight embedded system level. And based on this open source, we build our work and we have some demonstration recently. So the first project that we use the open source technology is the project so-called the ADEN for IoT, which is ultra low power sensor nodes. This slide demonstrates our one of our work using the Pumpino platform. So it's a sensor node which contain a CQ IoT system on chip, interface with USB, with sensor through GPIO or E2C interface, interface with Bluetooth low energy and LoRa transceiver, and the SD card, and it can transmit the LoRa package or Bluetooth low energy packet to an IoT gateway, and the gateway will send the data through the wide network, through the internet, and to the cloud computing. So this is the block diagram of our processor. So the processor is based on the Pumpino RISC-V core, which is the RISC-C processor with 32-bit instruction set architectures. We cooperate an AS data encryption core to the bus, and it can work with different AEAD mode. So the whole system is designed with the low power capability in mind. And the RISC-V core is used for configuration, control, and data acquisition. There's also some communication interface, for example, SPI, WAT, and E2C and GPIO. And we view the demonstration based on this component. So we have successfully demonstrated the whole system in on FPGA using the ACT A7 development board, and the system on chip with our encryption core is put into the FPGA along with the LoRa transceiver and the programmer. And our system also have been taped out in September. The tutorial of the AS encryption core and the control and the interface is about 23 kilo gate equivalent with the throughput of about 103 megabit per second at 60 megahertz, and the power consumption is about 0.7 milliwatt. For the encryption core and the full chip consume about 10 milliwatt. We also our student also designed a teeny neural network IP, and we also integrate this IP into the Punpino platform. So this is a very small neural network. We can perform number recognition, handwritten number recognition, and our students have demonstrated different multiply and add architectures. For example, the architecture use normal multiply and add using multiplier, and we also have the mark using the stochastic computing and the variable bit precision mark without the using DSP or multiplier. This is the hardware utilization of our architectures. So the whole chip, the whole system on chip with processor and the ANN IP on ACT A7 100, and it occupy only a very small area with only 10% of the flip-flop and the 30% of loops and 3% of DSP, and the number of RAM is quite large, 75%. And for the low power part, we also work on power optimization for a very large scale RISC-V system using the network router. This work is based on the system from the BSG many core project. And in this work, we propose a power gating technique for multi-core RISC-V system based on the remote store programming. We divided the system into two parts: the RISC-V core and the memory crossbar. And the power manager depends on the load of the system. We choose to power gate the RISC-V core or even the memory. So next, we would like to present our research and training direction. So we go back to the key issue of the IoT. So for IoT, we think that multi and many core system on chip will be important to provide different workload for IoT. They also need the testability and reliability. And so one of our direction is working on the reconfigurable and fault-tolerant architectures for processor. For the low power part, so we also try to develop some low power technique from the architectures to implementation. For security and privacy, We are currently focused on hardware cryptography design, not only for traditional algorithm, for example, AES, but also include the new lightweight cryptography. For example, the candidate for the second round of NIST competition for lightweight cryptography. And we think that IoT sensor node also need the AI, and so we also focus on the hardware acceleration for artificial intelligence. Um, so hardware design in Vietnam is not yet very developed. So uh, we see that the open source hardware can be benefit for Vietnamese student, researchers, and company. So in the long term, we would like to build an open source hardware community for Vietnam to share experience, how tools, know-how, and resources for Vietnamese and also for other collaborator outside of Vietnam. We would like to support other university and company and startup also, so that we can push the hardware design industry in Vietnam. And for our lab, so we are currently adopting CHISO and ChipYard for our project, and our new project will be built around the open source ecosystem, including CHISO and ChipYard. And for education and training, from 2020, so for students to go to our lab, so they will have training on CHISO, and CHISO will be the main hardware constructing language for us to fasten the development of many systems. And finally, I would like to make some conclusion. So open source hardware is maturing. It means that there's a lot of available platform um, for university, and they are ready to use. Um, they they have many good features, and we can save a lot of time by using them. And this open source hardware open new opportunities for us. For example, we can focus on improving there's power consumption features. We can try to improve the security, and we can reuse them for high performance system, for example 5G and AI, which is um, one of the key trend that Vietnam's want to develop also. And um, as a member of university, we are willing to help student, startup, and company in Vietnam in this field. So thank you.
Thank you very much. So please submit the question to Slack or Twitter. Any question? I have a question. So uh, you and your student create the commercial grade chip. So what is the application for those tip
So mostly,
chip?
so we are focused on the ultra low power and ultra low cost system for IoT. And one of our main feature is on the to ensure the security using data encryption and so on. But it needs to be small and power efficient.
Thank you. Any question from audience? So you use a chip alliance product. So do you like chip alliance?
So for chip alliance, we not yet use it yet. So the
Not yet.
our current base platform is based on the POOP platform, the based
Mhm.
on the Pumpino platform.
Oh, okay. Okay, thanks so much. There is no question from audience. Thank you.
Yeah, thank you and goodbye.
Goodbye.